In this sample problem, we will use the same cross-sectional areas obtained from sample problem 1. However, in this case, we will determine the volume of the given measurements using the Prismoidal formula. The formula for computing the volume of earthworks using the Prismoidal method is L/6 multiplied to A1 plus 4 times AM plus A2. Here, A1 is the cross-sectional area at station 4 plus 400, while A2 is the area at station 4 plus 420. For AM, this represents the area at the midpoint of the earthwork section. To determine the middle section, we compute the average values of the corresponding points from the two given cross-sections. Starting with the left top point, for the vertical component, we average 2.65 and 2.35 to get 2.50. For the horizontal offset, averaging 9.80 and 9.20 gives 9.50. Next, at the centerline, we average the vertical values 1.20 and 1.00, which results in 1.10. Then, for the right side, we average the vertical components 0.80 and 0.70 to get 0.75. Similarly, averaging the horizontal offsets 5.20 and 5.30 gives 5.25. After arranging these average values, we obtain the measurement points for the middle section at station 4 plus 410. These values will then be used to plot and compute the cross-sectional area of the middle section. Now, let's illustrate the middle section by first sketching the grid and drawing the road base at the center. Next, we plot the computed points. Starting at the center line, the horizontal position is 0 with a vertical value of plus 1.10. Then, we plot the left point at a horizontal offset of 9.50 meters with an elevation of plus 2.50. Lastly, we plot the right point at a horizontal offset of 5.25 meters with an elevation of plus 0.75. After plotting these points, we connect the upper left and upper right points to represent the ground surface. Then, we draw lines from the left point to the left edge of the road base, and similarly from the right point to the right edge of the road base. From the highlighted portion, we can now divide the cross-sectional area into segments. Next, draw a line from the upper left and right point down to the center line of the road base. After dividing the section, label the segments as A1, A2, A3, and A4. Now, let's compute each area. First, for A1, it is equal to 1/2 times the base, 4, times the height, 2.5. A1 is equal to 5. Then, for A2, which is equal to 1/2 times the base, 9.50, times height, 1.1. It is equal to 5.225. Next, for A3, it is equal to 1/2 times the base, 5.25, times the height, 1.1. A3 is 2.8875. Lastly, for A4, it is equal to 1/2 times base, 4, times height, 0.75, which is equivalent to 1.50. Adding all the areas, we obtain a total of 14.6125 square meters. This value will be used as AM in the Prismoidal formula. Now, we apply the Prismoidal formula for volume, which is equal to L/6 multiplied to A1 plus 4 times AM plus A2. Substituting the values, we obtain 292.3333. Therefore, the volume of the earthworks using Prismoidal formula is 292.3333 cubic meters. And that completes our solution using the Prismoidal formula for earthwork volume. Try comparing this result with the end area method to better understand the difference in accuracy. Keep practicing, and I'll see you in the next video.